So this is the Blincolnlights panel with the TX-0 simulation, and I'm going to demonstrate the panel and the TX-0 and how to use it. So first of all, we turn it on with a power switch. And now we can see two rows of lights and one row of switches. The original TX-0 had more of these, so we have this little selector here for to show which register is being displayed. On the top we see the accumulator and the live register on the bottom. And to load the two switch registers that are sort of simulating the two rows of switches, we can use these load buttons for the accumulator and MBR test switches. And we're going to do that. So what we want to do is execute some instructions in test mode, which is a mode where you can execute single instructions usually. So we have the instruction set here. It's very minimal. And what I want to show is, for instance, the clear left accumulator instruction. So we set the instruction bits to 1, 1 for the operate group, and then the next bit to a 1 to clear the left half. So let's do that. So set these to a 1, and the next one as well. So this should clear the left half of the accumulator. So now we load it into the MBR test switches, TBR it's called. And then with this button, we can execute it. And you see that the left half of the accumulator has been cleared. Now let's try another one. So cycle right, for instance, which will rotate all the bits in the accumulator to the right. And we just have to set 1, 1 in this position. So let's do that. Goes back to 0 and 1, 1 here. So again, load and execute. We can execute this a number of times, and this will rotate the accumulator. So this is fun. But we can also examine memory. And to do this, we use the add instruction. As you can see on the instruction set, add is a 0, 1, and then the address that we want to examine. So 0, 1, and then as an address, let's put these down again, we will use 5600 because that's where we have some code loaded. So 5600 in octal. And if we examine, we want to observe MBR, which is the memory buffer. So this gets the word from memory. So load it, execute, and that's indeed what's at that address. It will also be added to the accumulator, but this is not very interesting right now. What we can do is check MA, the memory address register. And because I have the step mode on, it will increment the address. So if we use the continue key, we can actually examine successive locations of memory, and MA will always be the next address to examine. So this would be at 1, 2 here, not 1, 3. Okay. Next we can maybe check out the live register. This one is directly connected to the simulated flexowriter, and if I type a key on the flexowriter here in the simulation, so for example an A, we see that the top bit will be set, and this gets the code for A. So this flexowriter code, it's not ASCII or anything like that. A, B, C, D, E, F. And by checking the top bit, the computer can see whether there was a new character typed. Okay, so maybe let's deposit this into memory. We can also do that. Okay, so to do this, we want to... No, this is actually too complicated. Let's not do this. Instead, let's start a program now. Okay, start will be done by a transfer instruction. Transfer of negative is just an unconditional start of the machine in test mode. So this is a 1, 0, and then the address where to start. So 1, 0, and then again 5, 6, 0, 0. And this will start UT3, which was a very early debugger and interactive system. So let's start it. So now it's running. And now on the FlexiWriter simulation, okay, these were the keys I typed earlier. But we can give it an address. So for instance, octal 40. And it will start disassembling instructions for us. So at 40, I have a little program that I will run shortly. And we can also see the numeric value of each instruction. And with the period key, I'm going can examine the next one. Can also type a new, like let's get into, okay, this is unused memory. So I can, for instance, type add, oops, well, that's not what I meant, error. Let's open again, add 1, 2, 3. And if we open this again, we see that the instruction add 1, 2, 3 has been deposited into memory. Okay, so now let's start this program at 40. So this is done by go to 40. And we see on the display, simulated display, we see a circle being drawn. And this is the Minsky circle algorithm, which only needs addition, subtraction, and right shifts. And of course a display. Okay, so let's stop the machine now. The stop key, and it halts, and the circle fades away. Okay, that was it for the demonstration.